All right, let's dive right in, shall we? Wormholes. I mean, the concept is just wild, right? We've got some pretty dense material to unpack here, but I'm excited to break it down and, well, figure out if these cosmic shortcuts are even remotely possible.
It's a question that has fascinated physicists and, honestly, anyone who's ever seen a good sci-fi movie for a long time now. And the funny thing is, even though they seem like pure science fiction, wormholes have a pretty solid basis in real science, in Einstein's theory of relativity, to be specific.
Okay, yeah, Einstein. Relativity, space and time bending. I vaguely remember that from college. Can you give me a quick refresher on how his work essentially opened the door to this whole wormhole concept?
Of course. So imagine right before Einstein came along, everyone pretty much saw space and time as this fixed, unchangeable thing, like a stage where the events of the universe play out.
Got it. The stage is set and everything happens on top of it.
Exactly. But then Einstein comes along with his theory of relativity, and he completely blows that idea out of the water. He shows us that space and time aren't separate. They're actually woven together into this fabric we call space-time. And here's the kicker. This fabric isn't static, it's dynamic. It can be warped, it can be stretched by the objects within it.
Right, right. It's like that analogy, the one with the bowling ball and the trampoline. The bowling ball represents a massive object, and it creates a dip in the trampoline, which represents gravity.
Exactly. You got it. Now, let's take that analogy a step further. Imagine an object so massive, something like a black hole, that it warps spacetime to an extreme degree, like really extreme. And that warping, well, that could create a kind of tunnel, a shortcut through spacetime. And that, my friend, is essentially a wormhole.
So, in theory, instead of spending centuries or even millennia traveling the vast distances between stars, you can just hop into a wormhole and zip across the universe in a blink of an eye. Sign me up.
Well, it's not quite that simple, unfortunately. There are a lot of complexities and challenges, not to mention we haven't even found a wormhole yet. But the concept is tantalizing, right? It's not just about speed either. Wormholes could potentially connect regions of space-time that would otherwise be completely unreachable.
Which brings us to, of course, the idea of parallel universes. Could a wormhole actually be a portal to another dimension?
Now that's a question that gets everyone excited, and it's tied to a specific type of wormhole called an Einstein-Rosen bridge. These were actually the first theoretical wormholes ever proposed, and physicists believe they're linked to black holes.
So you're telling me the entrance to a parallel universe might be through a black hole? No, thanks. I think I'll pass. Those things don't exactly have a reputation for being hospitable.
Yeah, that's the thing about Einstein-Rosen bridges. Well, let's just say they're not exactly ideal for interdimensional travel. For one thing, they're incredibly unstable. They tend to collapse almost as soon as they form.
So even if you could survive the intense gravity of a black hole, you probably wouldn't make it through the wormhole before it imploded.
Exactly. Plus, even if it didn't collapse, the journey through an Einstein-Rosen bridge would likely take an infinite amount of time. And then there's the whole question of what would be on the other side. Some theories suggest that the exit of an Einstein-Rosen bridge might be something called a white hole.
Okay, wait, a white hole. What in the world is a white hole?
Well, think of it as the opposite of a black hole. Instead of sucking everything in, a white hole spews matter and energy out, kind of like a reverse Big Bang.
Hold on, that doesn't make sense to me. If a black hole's gravity is so strong that nothing, not even light, can escape, how could anything possibly come out of a white hole? Wouldn't that completely contradict the laws of physics?
It's definitely a head scratcher, and honestly, it's puzzled physicists for decades. Some argue that white holes could be connected to other universes, or maybe even to different points in time within our own universe. But for now, white holes are pretty much theoretical objects. We haven't actually observed one.
So Einstein-Rosen bridges are interesting, from a theoretical standpoint at least, but they don't exactly sound like the kind of wormholes we'd be lining up to use for interstellar travel.
Nope, not really. Luckily for us, our source material also mentions another type of wormhole called, wait for it, traversable wormholes. And as the name suggests, these are the kind of wormholes that we could, actually traverse.
Okay, so we've got these traversable wormholes, but if Einstein-Rosen bridges are so unstable, how could a traversable wormhole possibly stay open long enough for a spaceship to pass through?
That is the million-dollar question, and to answer it, we need to get into some truly mind-bending stuff. Things like cosmic strings and exotic matter.
Oh boy, I can already feel my brain starting to hurt, but all right, hit me with it. Let's get into the weird stuff.
Keeping a wormhole open and, stable enough for something to actually travel through it, that's a pretty big hurdle. But this is where the idea of cosmic strings gets really interesting.
Yeah, we left off talking about those. Refresh my memory. What exactly are cosmic strings again?
Okay, so picture this. Incredibly dense, but like super thin filaments of energy left over from the Big Bang, stretching across like unimaginably vast distances.
Okay, so they're kind of like the scaffolding for a wormhole. They keep it from collapsing in on itself.
That's the idea, yeah. It's a pretty compelling theory. Some physicists think these cosmic strings, if they're even real, could thread through wormholes, kind of act like the support beams, if you will. And get this, string theory, which is a whole other can of worms, suggests that there might be a whole network of these wormholes all woven into the fabric of the universe, like formed right after the Big Bang.
A whole network. You mean like wormholes connecting distant galaxies
Hmm.
or even different points in time within our own universe? That's incredible, but also kind of terrifying.
Mm-hmm.
Wouldn't that create all sorts of paradoxes, like, the classic grandfather paradox?
You're thinking along the right lines. The whole time travel aspect of wormholes is, well, it's definitely one of the most fascinating and potentially problematic aspects. I mean, if you could travel back in time and actually change the past, wouldn't that lead to all kinds of logical inconsistencies?
Yeah, like
Mm.
imagine going back in time and accidentally preventing your own birth. That's a mess I'd rather avoid. So, how do physicists even try to make sense of these potential paradoxes?
Well, there are a few different ideas floating around out there. Some physicists believe that the laws of physics, as we understand them, might actually prevent those kinds of paradoxes from happening. Like, there's this thing called Novikov's self-consistency principle, and it basically says that anything you do in the past, it's already woven into the fabric of space-time. So even if you try to change things, events will always unfold in a way that makes sure your present remains consistent.
So you're saying it's like the past is unchangeable, even if you could travel back in time. Interesting. But let's move on to this exotic matter stuff. You mentioned it earlier, and it just sounds, well, exotic. What is it, and how does it factor into all of this?
Right, exotic matter. Okay, so full disclosure, this is still very much hypothetical, but the theory is that exotic matter has negative mass, meaning it would actually repel regular matter, like it would have a kind of anti-gravity force.
So instead of pulling things together, like gravity does, it would push them apart.
Precisely. And that repulsive force, that's what we'd need to counteract the immense gravitational pull of a wormhole to keep it from collapsing.
Okay, I think I'm getting it. So it's like, imagine you have a balloon, and you need to keep it inflated, so you need something to push against the inside of the balloon to keep it from deflating. But instead of a balloon, we're talking about a tunnel in space-time. And instead of air, we're talking about anti-gravity.
You got it. It's a pretty wild concept, right? And the challenge, of course, is actually finding or creating this exotic matter. We haven't observed anything like it in nature yet, at least not that we know of.
So where would we even begin to look for something like that?
Well, some physicists think that the answer might lie in the quantum vacuum of space itself. Now, when we say vacuum, we don't mean it's actually empty. It's actually teeming with these virtual particles that are constantly popping in and out of existence like super quickly.
So you're saying that the empty space between stars, the vacuum, it's not actually empty. It's full of these tiny particles that we can't even see.
Exactly. And the idea is that maybe, just maybe, by manipulating these quantum fluctuations, we could trick the universe into creating the effects of negative mass.
So we're talking about harnessing the weirdness of quantum mechanics to build a stable wormhole. Okay, officially mind blown.
Yeah. I know, it's a lot to take in, but the implications are enormous. If we could actually create stable, traversable wormholes, I mean, it would revolutionize space travel as we know it. We could reach distant star systems in a matter of days, weeks, maybe even hours, instead of, the thousands of years it would take with our current technology.
It'd be like having a cosmic freeway system connecting all corners of the universe.
Exactly. And just imagine the scientific possibilities. Studying distant stars and galaxies up close, maybe even encountering other civilizations. But like we talked about earlier, we got to proceed with caution, right?
Yeah.
The time travel paradoxes, those are just one potential problem.
Right, right. What else should we be worried about?
Well, creating a wormhole in the first place, that would require an insane amount of energy, like more than we can even fathom right now. And we'd have to be really, really sure that we could control the process. I mean, unintended consequences are always a possibility when you're messing around with forces that powerful. And then there are the ethical implications too, like what would be the impact on the regions of space-time that we're connecting? What if a wormhole became unstable? or collapsed entirely. We'd need to think long and hard about all of that before we even attempt to build one.
Yeah, it's like we'd be opening a door to the unknown. We might not like what we find on the other side or what comes through to our side.
Which actually brings us to another fascinating possibility. What if we don't even need to create wormholes? What if they already exist naturally? Like, what if some of those supermassive black holes that we see at the centers of galaxies, what if those are actually wormholes in disguise?
Now that's a thought. Instead of trying to build our own, maybe we just need to figure out how to identify and utilize the ones that are already out there.
Right. And if there are natural wormholes out there, they might connect us to parts of the universe or even other universes that we never even dreamed possible. It's pretty exciting stuff.
It is. But I have to be honest, my brain is feeling a bit overloaded right now. We've covered a lot of ground.
I hear you. It's a lot to process. But that's kind of the nature of exploring these big mysteries, right? We challenge our assumptions, we push the boundaries of our knowledge, and sometimes we end up with even more questions than we started with.
That's true, and I think it's that sense of wonder, that drive to keep asking questions that keeps us moving forward. But we've talked a lot about the theoretical possibilities of wormholes. What about the practical side of things? Do we have any actual evidence that they might be real? Or are they just a fascinating mathematical concept?
Now that's the question, isn't it? And it's a tough one to answer. Let's dive into that in the final part of our deep dive.
All right, so back to wormholes. We've talked theory, we've talked possibilities, but the big question still remains. Is there any actual proof that these things exist?
That's the holy grail, isn't it? But finding a wormhole, it's not like spotting a new planet through a telescope. It's way more complicated than that.
Yeah, I can imagine. They're probably tiny, incredibly dense, and maybe even hidden inside those crazy gravitational maelstroms we call black holes.
You're exactly right. Directly observing a wormhole with our current tech, well, it's pretty much impossible, at least for now. But that doesn't mean we're completely clueless. There's some indirect ways we might be able to figure out if they're out there.
Indirect ways. Okay, now you've got me curious. What are we talking about here?
One way is to look at how stars behave near suspected wormholes. If a wormhole was hanging out near a star, its intense gravity would warp the star's light in a really specific way. It'd create this lensing effect.
So, like, by studying how light bends around a massive object, we could tell if it's a black hole or a wormhole.
You got it. There'd be subtle differences in the lensing patterns that could give us a clue.
Wow, that's pretty clever. Are astronomers actually looking for these patterns?
Oh yeah, definitely. There are some awesome projects going on right now using really powerful telescopes to map the distribution of mass in the universe. And they're keeping an eye out for any weird gravitational anomalies that might, hint at the presence of a wormhole.
I see, so it's like a cosmic treasure hunt. And what about those cosmic strings we talked about earlier? Could they help us find wormholes too?
They could, actually. If cosmic strings exist, they'd create these tiny little distortions in something called the cosmic microwave background radiation. You know, that faint afterglow from the Big Bang.
Right, I remember that from our deep dive on the Big Bang.
Well, if we could detect these distortions, that'd be another piece of the puzzle, another hint that wormholes might be real.
So it's kind of like putting together a giant cosmic jigsaw puzzle, huh? Looking for clues everywhere we can.
That's a great way to put it. And even though we haven't found that definitive aha moment yet, the search itself is teaching us so much. It's pushing the limits of our telescopes and our understanding of the universe.
So even if we don't find a wormhole tomorrow, the journey is still worth it.
Absolutely. And who knows, maybe someday one of these searches will turn up something truly amazing.
That would be incredible. But I have to say, even if wormholes remain this tantalizing mystery, I think our conversation today has really highlighted something pretty remarkable.
What's that?
The power of human curiosity, our drive to understand the universe and our place in it. I mean, the fact that we can even imagine these crazy ideas like wormholes and then come up with ways to search for them, it's kind of mind-blowing, don't you think?
I completely agree. It's what makes us human, right? This constant need to explore, to push the boundaries of what we know. And even if wormholes turn out to be just a figment of our imagination, the journey of exploring them, well, that's what enriches our understanding of the cosmos.
Well said. So on that note, I think it's time to wrap up our deep dive into the fascinating world of wormholes.
It's been a wild ride through some seriously mind-bending physics. We've journeyed from Einstein's theories to the edges of the observable universe, and hopefully we've sparked some curiosity along the way.
I think we have. And to our listeners, I want to say, Never stop asking questions. Never stop exploring. Keep that sense of wonder alive, because who knows what incredible discoveries are waiting for us out there in the vast expanse of the universe.
That's right. There's a whole universe of mysteries waiting to be uncovered. Keep looking up.